Okay. By how much is theta going to change, right? So, first of all, what you're going to do is always write down the principle of conservation of momentum. Okay. The principle of conservation of momentum is momentum before, some momentum before equal to some momentum after in all directions, right? Which means momentum is going to conserve horizontally as well as vertically. Okay, excellent. Now, first of all, let's check. Hmm. Let's write down horizontal momentum conservation separately and vertical one separately. That's the first thing that you should always do whenever you've got 2D momentum. Okay. Now, so what is the horizontal total momentum? I think horizontal sum before and then sum after. Okay. What is the total momentum before collision? Horizontally, I think it's the mass of the asteroid with its horizontal velocity, right? That's going to be 6.1 into 10 is power 10 multiplied by what is the horizontal velocity? That's 12.6 kilometer per second. Be careful. So that's going to be into 10 is power 3. Okay. Okay. Plus, does the impactor have any horizontal velocity? No, it's zero. Okay. And what would be the total horizontal velocity after? Now, think about it. This is at an angle, which means after the collision, both of these stick together, right? And if they stick together, that means they have a collective velocity. And this velocity is going to be slightly to the right and slightly upwards as well, right? Because you see that it's going to have two components. It's going to have a horizontal component. It's going a lot of right and it's going a little bit up as well. What would be the horizontal part? That would just be V cos alpha, right? So that's the horizontal component. Okay. Then plus, what is the total horizontal velocity after collision? That's just going to be the sum of the masses. So that's going to be 6.1 into 10 is power 10 plus 4,000. Okay, this is the mass multiplied by the horizontal velocity. What is the horizontal velocity? That's V cos alpha. Okay, or you can also write it as V horizontal. Okay, V cos theta or V horizontal is the same thing. So V horizontal. Okay, then now this is
We
the
write it
horizontal conservation. What are you saying?
we write it as B horizontal again because like the angle we don't know it, right?
We
That's
don't know the angle. Absolutely, absolutely. So it would be smart to write it as V horizontal because we don't need to calculate theta out of, the first equation. You can use theta in a smart way by doing it later. Okay. I think, how about we first calculate the horizontal velocity? Let's do it. So do take out your calculators. Let's check. I'm going to write down these questions for you and do plug in the answer 112.6 into 10 to the power 3. Then this is divided by 6.1 into 10 to the power 10 plus 4,000. Can you plug this in? And this will give me V horizontal. Once we get to the end of the question, you will see why are we doing this. 6.1 into 10 to the power 10 multiplied by 12.6 into 10 to the power 3, then divided by 1 into 10 to the power 10 plus 4,000. So that's going to be VH is going to be 12,599. No, wait, 12,599 meters per second. Okay. Or
do we not
it could
add
also be,
decimals?
what are you saying?
Do we not add decimals?
Where you can add that as well. It's 9.999,
Okay.
right? So 12,599 meters per second. Okay. So that's what this answer should be. This is the horizontal velocity, right? So after they move together, right? The rocket and the impactor and the asteroid, they move together with a horizontal velocity of 12,599 meters per second. Okay. Now, what if we also calculated the vertical velocity? If you calculated the vertical velocity, wouldn't it be easy to calculate what the velocity was and what theta was? Yes, it is. Right. So let's calculate the vertical velocity. Now, for vertical velocity, you will have to consider the vertical components of the vertical momentum. You will have to consider whether momentum is conserved in the vertical directions. It is. Some momentum before collision should equal to some momentum after collision, but only for vertical components. Does this one have any vertical component? No, it's only horizontal. So 0 plus. Does the impactor have any vertical velocity? Yes, it is entirely vertical. So that's going to 4,000 multiplied by 6 into 10 to the power 3. 4,000 multiplied by 6 into 10 to the power 3 because it's kilometers per second. Okay, so that's the vertical momentum before collision. What is the vertical momentum after collision? It's going to be this mass multiplied by the vertical velocity, but this is going to be v sine alpha, or that's just v vertical, right? Okay, so that means what will be the sum of momentum after collision? That's going to be 6. No, wait, what was the mass of the? Okay, it was this. It was this value. Okay, into the vertical velocity, right? What was the vertical velocity? That's just going to be v sine alpha, or it's just useful to write it as v vertical. Okay, that's how we'll calculate the vertical velocity. Now, plug that into your calculator. That's going to be 4,000 into 6 into 10 to the power 3 divided by 6.1 into 10 to the power 10 plus 4,000 equal to v vertical. This comes out as 4,000 multiplied by 6 into 10 to the power 3, 6.1 into 10 per. That is 3.93 into 10 raised to power minus 4 meters per second. This is the vertical velocity. Now, you have the horizontal velocity. You have the vertical velocity. That means we now have both components of this resultant, right? So that means we also know, we know that VH is 12,599, and we know that V vertical is 3.93 into 10 to the power minus 4. Can we use this to find out the resultant velocity V? Yes, we can, right? If you have two sides of the right triangle from this vector, then it's very easy to calculate the resultant velocity V, right? Just like in vectors. So what is this going to be? 12,599 squared plus 3.93 into 10 to the power minus 4 squared. When you take the under root, this is going to equal to V, resultant velocity V. Let's check it out. 12,599 plus 3 point. Be careful in using the brackets and the powers. Into 10 to the power minus 4 squared. Okay. So velocity turns out to be 12,599 roughly. Why? Because look at it. You are adding a very, very small number to a very, very large number, right? So why is it, it's not going to change much. It might be, 0.000 something, but it's not going to change much. Okay. Now, how about we calculate this theta, right? The goal of the question was, what is alpha, right? By how much angle does the trajectory change? Because our entire goal was, by how much angle can we change this trajectory by shooting this at a certain speed? Let's calculate theta. We can calculate theta by just using tan theta, right? Tan theta is equals to, perpendicular over base. And what is theta? Theta is going to be tan inverse. What is the perpendicular value? That is this one, 3.93 into 10 to the power minus 4 divided by, what's the base value? 12,599. Let's calculate what theta is. Divided by 3.93 into 10 to the power minus 4 divided by 12.5. So theta is 1.78 into 10 raised to power minus 6 Okay, and that's what theta is. This is how much trajectory you can change it by shooting it at this speed and with this mass. So like if you shoot it at a right angle, right, it's going to collide it like this. But how much is it going to change its trajectory? Its angle is only going to change by 1.78 into 10 to the power minus 6. Okay, so that's how you figure out by how much does the trajectory change. Okay, it's all just, vectors and conservation of momentum in a single dimension. You compare it with horizontal, then you compare it with vertical, and then you just use, vector resolution, and then you figure out theta. Now, what do you think? Is this significant? By the way, any questions up till this point? All good?
Yeah.
Yes. Yes, Hania? Any problems in this part? We've covered all of this before.
No, I got it.
Okay. Yes, Kaima, Abiha? Any questions up till this point? No?
No.
Okay.
No questions.
Now, okay. Now, what do you think? Is this significant enough? Is this angle change really significant? What do you think?
I don't think so.
No, it's not significant enough. Okay. What do you think, Anya?
No, I think it's really
It's
small.
it's really small, right? It's like 0.000000178 something. Okay, you're right. Now, this is actually significant. This is actually significant. Why is it significant? Because your trajectory may even like a very small change in your angle is going to make your direction very, very different. For example, think about it. If you're on a plane, okay, this is the plane, and initially you had to go from this point to this point. Okay. What if, I'm going to take out my ruler, and let's say that I change the trajectory of the plane by just like 1 degree. So 1 degree is going to be roughly here. So if I just, move slightly, if I just move 1 degree ahead, I, change my trajectory by 1 degree, check it out. Does my path change? It does. Do you see that it's as the, distance is moving further and further and further ahead, the angle, even though it's like 1 degree, right? Even though it's 1 degree, the path is changing by a lot. And imagine if you keep on increasing the distance, those lines are going to become much further and further and further apart. This is going to, as you keep increasing the length of this line, as you keep covering more distance, these points are going to become much further and further apart. And because the asteroid is so far away, if you collide it a much greater distance away, if you change the trajectory by even like 0.00001, but you change it, 500,000 kilometers away, that is a very significant change because, by the time it gets here, it will have changed its trajectory by so much, right? That, you're going to completely avoid collision. Okay, so that's why this is pretty significant. Even a tiny change is good enough. We're not, we don't want to change it by, like 30 degrees. We want to change it by a very small amount, but a much further distance away. But yes, if the asteroid is pretty close to Earth, then of course you will have to change it by a lot of value, right? For example, if this is the asteroid and this is Earth, right? You will have to change it by roughly, if this is 0 degrees, then you'll have to alter its position by at least, uh, like at least 10 degrees or 12 degrees. So if you change it by 12 degrees, only then is it going to miss you. Okay, but if it's much further away, if for example, if this is where it is, even much further, if this is where it is, then you can check that you only need to change it by, let's make it even further. So yes, this is the asteroid. Over here, you only need to change it by roughly, check it out, 3 degrees. So that means even if you change its trajectory by 3 degrees, it's going to barely miss Earth. Okay, so the further you are, the lesser angle you have to change it by. Okay, so that's the idea.
Sir?
Yes.
But if we like narrowly make it miss the Earth, then like won't the gravitational pull anyways like pull it towards Earth though?
Yes, it depends upon how close it is. So for example, this is taught in, gravitation. So for example, if this is the Earth, okay, and you have a comet, in fact, that's what we call comets. So comets, for example, if a comet actually has a velocity in this direction. Now, if it's too close, okay, if it's too close, then what could happen is, if it's like tangent to the Earth, then because of Earth's gravitational pull, it could attract the comet into a circular path and then slingshot it back to its path. Okay, but what could happen is then it could come back as well and it could keep on continuing in an orbit. It could keep on continuing in orbit. It comes close, it slingshots back, it's come close, and it's going to slingshot back. That's what happens to a lot of comets. But some comets, they just have so much velocity that the Earth slingshots them back into a very large orbit. Makes sense? But if the comet is falling, at like right angles to the Earth, like if it's coming straight towards Earth, then it's obviously going to crash over here. Okay. But if it's coming at an angle, then Earth is going to slingshot it back. But if it does not have enough velocity when it's coming, then it might just fall down at an angle. So it might fall down like over here. Okay. It depends upon the speed, depends upon multiple factors. Make sense? This is actually what you study in A2 gravitation. Slingshots. Why do the slingshot? Yes.
Yeah, but what I didn't understand is like how do they slingshot? That's the only thing.
That's related to the gravitational potential energy and the kinetic energy. Because imagine this. For example, if you have a ball on a mountain, it has a lot of gravitational potential energy, right? And if you
Yeah.
drop it, it's going to lose the gravitational potential energy and convert it into kinetic energy, right? I'm sure you're familiar with that. Now,
Yeah.
if you have a comet over here, because you are at a very large height from Earth, right? That means this comet has relative to the Earth, it has a lot of GPE. Okay. And over here, it has minimum kinetic energy, it has minimum velocity. But what happens if
Okay.
it's falling towards the Earth? GPE is decreasing. And where is that gravitational potential energy going? If an object is falling, what does it do? It catches speed in the form of kinetic energy, right? And as it's coming closer and closer to Earth, gravitational potential energy keeps falling and kinetic part keeps increasing, right? So now it has a very high velocity over here, right? But if it has a certain amount of velocity, it's not going to fall down, right? It's going to keep on continuing and Earth keeps curving its path. And then what happens is it continues in the opposite direction. Now what's happening is that the kinetic energy is being converted into gravitational potential energy again. So it's like a seesaw. Over here you have got a lot of potential energy. The ball or asteroid is falling and falling and falling. It gains a lot of speed, but because of the speed, it does not fall into the Earth. It continues around the Earth, and then as it keep going away, it's kind of like it's gaining potential energy and losing kinetic energy again. So like at the tail of the orbit, you've got very little velocity over here. Why? Because you used all of the gravitational potential energy into kinetic energy. Make sense? So, this is what we study in A2 gravitation, the comets, the orbits, what determines the value of the orbit, what determines the radius of the orbit, how do you find out this velocity at this point, how do you, for example, find out the velocity at this point, and all of that stuff. Okay, it's pretty interesting.
Yeah, I
It's one
kind
of
of
the most.
understand.
Mm.
Yeah.
Okay, it's pretty interesting. It's one of the best chapters in A2. Okay, sounds good. Yes, any questions? Should we move on? Okay, sounds good. Now, moving on. Now we're going to do this past paper question. Okay, the past paper questions is so it's again a 2D momentum question. And it's a slightly difficult question, which is including 3-mark question, then a 2-mark question, and then another 3-mark question. So this is like one of the most difficult law of conservation momentum questions in 2D. Okay. Question. Now be careful. If you have any question, stop me right there and then we'll discuss it. Now, ball A moves with the speed v along a horizontal frictionless surface towards a stationary ball B, as shown in figure 3.1. Okay. Then they collide, and both of A and B, ball A and B, they move together in opposite directions, right? This one moves towards this side, and this moves in this side. Okay, makes sense. Sounds good. This is just like, for example, a pool. Have you ever, seen, what do we call that? Pool, yes, 8-ball pool, right? So, for example, you're viewing from the top of the table, and this pool ball hits this ball, and both ball A and B, rather than stopping or rebounding, ball A moves towards direction theta, and ball B towards direction 30 degrees. 30 degrees towards the south. Okay. Now the question is, okay, they've given all of that. They've given all the velocity. Okay, the question is, by considering the components of momentum at right angles to the direction, okay, components of right angles to the direction of the initial path of ball A, okay, calculate theta. Okay, so you've got to consider this entire scenario and you've got to calculate theta. Okay, now I'm going to leave you for like 5 minutes and I want you to come up with an answer for this. Try to, because we've done like 2 to 3 examples compared to this, very similar examples. I want you to now try to apply that in finding theta. I'll give you 5 minutes and be right back by then. Okay. Try to use vertical conservation and horizontal conservation and vector resolution. You will be able to find out. In fact, it's much easier than the examples that we've done. Okay. I'll be back in 5 minutes. Yes. Any luck calculating theta? Yes, Abiha.
I'm doing the calculation now.
Okay. Yes, Anya. Have you gotten an answer?
No, I still need like 2 more minutes.
Okay. Yes, Kaima. Any luck solving it?
I think I need also need 2 minutes to solve it.
Okay. Okay. Yes, Ariz. Will you solve it or no?
So I'm doing it, but like it's just
Confusing. Okay. They've even given you they've given you a hint. By considering the momentum at right angles to the direction of the initial path of ball A. So he's talking about try to consider the vertical momentums. Okay, I'll wait 1 more minute and then we'll do it. It's a really good one. It's if you when you see me solving it, you will see that it was so easy. Ariz, have you seen these kinds of questions earlier? In your school or your exam or something? Or
no,
no?
she's not shown us these kinds of questions.
No? You haven't done these?
Not the component at right angle thing.
Oh, the 2D momentum questions.
No, like 2D momentum questions we have done, but not the ones with like considering the component at right angle.
Oh,
Wait, so I think I'm getting the answer. Just one sec though.
okay. Yes, Anya, have you done these 2D momentum questions in school or
Yeah,
by
but like I didn't get it.
Okay. Okay, now let's solve it. It says by considering the components of momentum at right angles, he's just giving you a hint, okay, that try to consider the vertical momentum. That's what he's trying to say. 1 second. Okay, now the hint was to consider the vertical momentums. Now, that means the sum of momentum before should equal to the sum of momentum after, right? In vertical direction. Okay, and in horizontal as well. But you'll see that in vertical, it'll become very easy for you to calculate theta. What is the total vertical momentum before collision? No, nothing. There's no vertical momentum. It's zero, right? Because this is only moving horizontally and B is not moving at all. So there is no vertical velocity, no vertical momentum before collision. So this is going to be zero. What is the total vertical momentum after collision now? This is going to have a vertical component, right? And what is going to be the vertical component? It's going to be this value. It's going to be this value. You can draw the red one over here or over here. So let's draw it over here. What is this going to be? Isn't that going to be 4 times 6 sine theta, right? And what about so this is like the vertical velocity of this ball A. And what is going to be the vertical velocity of ball B? You see that it's going downwards. So that means it's going to have a vertical velocity of 12, vertical momentum of 12 into 3.5 sine 30, right? Now, what is the total vertical momentum? Isn't it going to be 4 times 6 sine theta plus this is going to be negative. Why? Because you see that it's in the downwards direction, right? Because if upwards is positive velocity, downwards is supposed to be negative, right? So if this is positive, This is supposed to be negative. Okay. Then minus 12 into 3.5 sine 30. Okay. Now, the left side is 0. Doesn't that mean if you take that on the other side, this is going to become 12 into 3.5 sine 30 equals to 4 into 6 sine theta. And that's going to give you theta. That means if you divide this on the other side and you take sine inverse, and if you do sine inverse, what are you left with the right side? Theta. That means if you plug this in the calculator, this is going to give me sine inverse over 12 into 3.5 into sine 30 divided by 4 into 6. And that gives me theta as 61 degrees. So theta is supposed to be 61 degrees. So that's how you calculate it. Let me see if we have, did we do anything wrong? Yes.
For angles, do we have to like we can't use decimal places?
For what? You can. 61, it's actually 61.04. So, I just rounded off. You can use 61.04, that's fine as well. Okay, so that's how you calculate it. Because the vertical momentum before collision was 0. That means the vertical momentum after collision should also be 0, right? So these momentums must have been canceling each other out. So if you add up this value and you add up this value, right? This is positive, whereas this is negative. So that must mean, if you take that on the other side, you're just going to get sine theta, and then you can calculate theta from over here. So that's how you calculate this. Yes, any questions?
No.
1 second. Okay. Yes, Abhiha, does that make sense how we calculate theta?
Yeah.
Yes, okay. Kaima, make sense?
Yeah.
Anya, okay. Now, use your answer in 1 to show that the initial speed v of the ball is 12 meters per second. So he's saying that calculate this as 12 meters per second. We have not been given this. You've got to prove that it's 12 meters per second. Now, how do we prove that? Okay, now we have theta. Okay. Now, that means in this question, we'll have to use the horizontal components. Why? Because in the vertical components, this does not have any velocity vertically, right? So you can't use the vertical component to find out this velocity. You will have to use the horizontal ones. Now, we know that horizontally momentum before should also equal to momentum before and momentum after, right? Now, what is the total momentum horizontally before collision? I'm talking about horizontally. Okay. Now, it's going to be 4 times v, right? 4 times v plus 0. Why? Because, this is not moving. Okay. Equals to, what is the total horizontal momentum after collision? It's going to be this value plus this value, right? Because if you think about it, this is how much horizontally ball A is going, and this is how much horizontally ball B is going. Shouldn't this be 4 into 6 cos theta? And shouldn't this be 12 into 3.5 cos theta, right? So that's just going to be the horizontal components. In fact, let me write it down over here. Okay, so it's going to be 6 into 4 cos theta. In fact, now we already know what theta is. We know it's 61, right? So it's going to be cos 61. We know that this theta is actually 61 degrees. Then you add it with the horizontal component of the other ball, which is this value, right? This blue line. This blue line is going to be 12 into 3.5 cos 30. 12 into 3.5 cos 30. Why? Because m into v cos 30. Okay. Can we calculate v from this value? Yes, we can. So calculate this sum. And when you calculate this sum, you divide this entire thing by V. By 4, sorry. By 4. And that's going to give me V. Let's calculate. Try to plug it into your calculator and check what it is. So that's going to be that's going to be 6 into 4 cos 61 plus 12 into 3.5 cos 30 divided by 4. Okay. Yep, I'm getting V as roughly 12 meters per second. Yes, makes sense? That's how you know
So
you can
how
use
do
the
you
components.
how do you explain the working though?
So we know that horizontally momentum is conserved, right? Horizontal momentum has to be conserved. What is the total horizontal momentum? It's this value, right? This is the total horizontal momentum, which is what? It is 4 multiplied by V plus 0, right? Because this is not moving, so this has no momentum at all. What is the total horizontal momentum after collision? It's this yellow line plus the blue line, right? Because the
Yeah.
ball A has a horizontal momentum in this direction, and ball B also has a horizontal momentum in this direction. So that means if you add up, let me in fact highlight it. If you add up this value and you add up this value, they should be equal. So this line should equal to this line, right? And in doing that, we can calculate V, because what is the total momentum horizontally before collision? It was this left side, right? And what was the horizontal momentum after collision? It was this side, right? And in all of these variables, you only had one unknown, which was V, right? And we already had theta. For example, if we did not have this theta, then you would not have been able to calculate V, because now you have two unknowns. Let's say this, part one was unknown. That's why they asked us to calculate theta first, because if you did not have theta first, then you would not be able to calculate what, V is, because now in this equation, you have two unknowns. You have this unknown and you have this unknown. And that's why in the first part, you had to calculate theta first, because then you would have been able to calculate what the velocity was. Okay. So in these kinds of questions, you just have to be pretty smart about, which component should I take? Which component is going to make my life much easier? Because if you were to use the horizontal components to find this value out, you would not be able to do that. Why? Because, vertical components. For vertical components, this ball has no vertical velocity. So how would that even come into your equation of velocity? Okay, so that's how you think about it. And you'll start getting it, once you solve enough questions of this.
So
Huh,
I understood like the
huh.
working and all, right? But then
Yes.
they're telling us to explain it. So do we just
Hmm.
show our working to explain
Oh,
it?
yes, that's fine. So if you just, show this out, that's right.
Okay, all right.
Okay, you at least have to, tell them that horizontally some momentum before equal to some momentum after, and then you show the working, and that's all right. Okay,
Okay.
explain your working. That's what they mean. They haven't given any lines, so you don't need to, use any words. But if you've shown that V is this and V is this, blah blah blah, and your answer has been proven. Okay, you didn't write shown. Okay, now moving on. Next question. By calculation of kinetic energies, state and explain whether the collision is elastic or inelastic. This is the kind of question that you like, Ariz. State and explain whether the collision is elastic or inelastic. Now, they've even mentioned, by calculation of kinetic energies. Okay. Now try doing this yourself. This is 3 marks again. Think about it. I'm going to give you 2 to 3 minutes and then I'm going to solve it. You have all of the velocities. You can pretty easily calculate the kinetic energies. This was a question from October, November 2017, paper 2-3. Very tough question. And these occasionally pop up, and some students are completely blank of how to solve this. But this is why you take my classes, that you should be able to solve absolutely any question that any examiner gives you. You shall be the kings of physics. The kings and queens, sorry. If you solve enough questions of A-level physics and you get a really strong understanding of it, the first year of university is going to be extremely easy for you, because you have such an extremely strong skill of mathematics and solving problems and physics understanding of concepts. Yes, Kaima, what should we do?
Sorry, sir, you asked me something.
Yes, Kaima, what do you think we should do? Any idea?
Calculate the kinetic energy before and after.
Absolutely, 100%. So you just have to check what is the kinetic energy before and what is the kinetic energy after, right? And what is the kinetic energy before? So if it was elastic, then the kinetic energy before collision should equal to kinetic energy after collision, right? What is the kinetic? So now let's calculate the kinetic energy before. It's just a pretty simple calculation. 1/2 into mass into velocity. So mass into velocity. We're not going to take this because it's not moving. So 4 into 12 square. No, not 12. Sorry. Yes, 12 square. Yes, we already calculated 12 square. Okay. So this is total kinetic energy of 4. So it is equals to 1/2 0.5 into 4 into 12 square. So that's 288. Okay. Now what is the kinetic energy after? Let's check. Now in this case, you have two ball A and ball B moving. So that means it's going to be 1/2 into 4 into 6 square, right? Let's check. So 1/2 into 4 into 6 square. Is that 6? 6 plus 12 into 3.5 square. 12 into 3.5 square. Let's check that out. So that's going to be 0.5 into 4 into 6 squared plus 0.5 into 12 into 3.5 squared. So that is equal to 145.5 joules. And there you have proven it. Because this is not equal to kinetic energy before is not equal to before and not equal to kinetic energy after. Thus, inelastic collision. And there you have proven. Okay. And you can even explain it further that it must be lost. It is lost in other directions. Okay. Sounds good. So that's how you'll prove this. Yes, Aris, does that make sense?
So why don't we use the straight line values? Why do we use the final resultant momentum?
What do you mean? Oh, so you're
Like,
just talking about why did we not only use the horizontal components?
yeah, why didn't we not use horizontal?
Because, good question, because kinetic energy is scalar. Kinetic energy does not care whether you're going, horizontally or vertically. You have to just take the resultants.
Okay.
Okay, since kinetic energy is scalar, it's not vector. It does not care about the direction. So you just take what was it called? A resultant. So you take the resultant velocity over here, and you take the resultant velocity over here, and you take the resultant velocity over here, right? Because kinetic energy does not care about the horizontal and vertical ones. It cares about what is the final resultant value, right? For example, if a ball is going up with a speed of 2 meters per second and a mass of 1 kg, okay? In the same way, if a ball is going towards the right with 1 meters per second, 2 meters per second of speed with a mass of 1 kg, what is their kinetic energy? It's same because in kinetic energy, you do 1 over 2 into mass into velocity squared. Velocity squared, right? When you plug in the values, both of these will have the same kinetic energy, same kinetic energy. Why? Because kinetic energy is a scalar quantity. Even if, for example, if you had positive velocity over here, and in the other example, you had negative velocity -2, let's say, just for example, the positive and the negative is going to square up to always give you a positive value. So even then, it won't make a difference. Okay. So that's why, for kinetic energy, you just use the resultant velocities. Okay. We'll do these MCQs later. Now, another question that is similar to this. Two balls, X and Y, move along a horizontal frictionless surface. Okay. Interesting. So again, you're playing, pool balls. X moves at a speed of 3 and they hit together at B. Okay. And this angle is 60 degrees. Ball X has an initial velocity of 3 meters per second in a direction along AB. Okay. Ball Y has a mass of 2.5 kg and an initial velocity of okay. Okay. Now, two balls collide at point B. They stick together. Oh, okay. And then travel along the horizontal frictionless surface at right angles. Okay, so they travel over here. Now, this seems pretty scary. By considering the components of momentum in the direction from A to B, so that means he's already giving you a hint. Consider the horizontal components. Why? Because, A to B is horizontal. Show that ball X has a mass of 4 kgs. Good question. Try doing it on your own first. I gave you 2 minutes to think about it. It is simple. It's only worth 2 marks and you will be able to solve it. Yes, Hania. How do you solve it?
We're gonna write the equation and then we're gonna make like the
Hmm.
mass the subject.
Okay, so do I consider horizontal momentums?
Yes, only horizontal.
Okay, so sum of momentum before is equal to sum momentum after, but I'm only considering horizontal momentums in this case. Okay, show that the ball X. Now, what is the total horizontal momentum before collision? That is, so that's going to be m into 3 plus, what is going to be the other one? What is going to be the other one? How do I find out the horizontal momentum of this ball? What do you think? Any idea? Yes, Ariz. Any suggestions?
Till
Right? Because
now,
are you stuck here as well?
I'm still. I think I could do it, but I'm just still reading.
Yes, Abhi, any suggestions? How do I write the horizontal momentum of ball Y?
I don't know. I think I just guessed and I didn't include it in the
Okay.
equation.
Because that means you have to consider the horizontal momentum of this ball. You have to consider the horizontal momentum of this ball. And then after collision, they will have zero horizontal momentum. Why? Because both ball X and Y, they're only moving vertically. So they have no horizontal momentum after collision. Okay, now what we're going to do is now think about it. If this is the line, this is your reference line. Okay. Now, if this angle, this is from IGCSE. If this angle is 60 degrees, then this angle is going to be 60 degrees as well. Right? This is, I think we call them parallel angles, right? So if you have this line and you have this line, right? And then you take this perpendicular line between them, not perpendicular, but passing through these, then this angle and this angle is going to be equal. Or what you could also have done is that if this is 60, then this is also 60, right? If you have a cross, then this is 60, and then this is also going to be 60. And in that case, if you found out that this side is 60, right, then these angles make a Z. That means this is 60, and then this should also be 60, right? So no matter what you do, you have figured it out that this line is going to have a 60-degree angle as well. Which means, do you see that this ball Y has a horizontal momentum in this direction, towards the left? It has a horizontal momentum towards the left. So that means if you take the horizontal momentum, it's going to be towards the left side. So it's going to be 2.5 multiplied by 9.6 cos 60. Cos 60, right? Why cos 60? Because you want the horizontal momentum, but it's going to be negative, because if you take the right side as positive over here, then do you see that this ball is moving towards the left side? So it's going to be negative. Okay. Now, what is the horizontal momentum of ball Y? It's going to be minus 2.5 into 9.6 cos 60. Okay, so that is the total horizontal momentum before collision. If you add up, the horizontal momentum of X and horizontal momentum of Y. And then what is the horizontal momentum after collision? It's zero. Why? Because this has only moving vertically, only vertical movement. And if it's only moving vertically, that means horizontally, the momentum would be zero. Okay. Now, can you substitute M? Yes, pretty easy. So that means M is equals to 2.5 into 9.6 cos 60 divided by 3. And if I get this, I'm going to get an answer of 4 kgs. Okay, so that's how you solve this question. Yes, Ariz. Do you get it?
Yeah, I mean, like I got the answer like already. I was able to
Okay,
get it.
sounds good. Okay, yes, Kaima, did you get it?
Yeah.
Okay. Now, so you've got to be careful about the directions. Keep in mind, in 2D momentum, it will always be easier to try to consider in which direction do momentums add to zero, because that will make your life much easier. If you have a single zero momentum anywhere, it's going to make your life much easier. In this case, like For example, horizontal momentum after the collision is 0 in this case because the ball is only moving vertically. So it's going to make your life much easier, when doing the question, because this adds up to 0. Okay. Now, calculate the common speed v of the two balls after the collision. Now, how do I calculate the common speed v? Now, this has to be in vertical momentum equation. Why? Because horizontally there is no velocity. It's not moving horizontally. So you have to consider the vertical momentum. Okay. So that means vertically, we know that the sum of momentum before collision should equal to sum of momentum after collision, right? Now, what is the sum of momentum before collision? Let's check it out. A vertical momentum. Now, vertically, this is not moving. Ball X has no vertical momentum. It's moving only to the right. So this is 0. Plus, what is the vertical momentum of ball Y? Yes, we know the angle. So if we know the angle, doesn't that mean this angle is going to be 2.5 into 9.6 sine 60, right? It's a vertical component. So that's going to be 2.5 into 9.6 sine 60, okay, equal to, what is the, no, wait, 1 second. Oh, this was, all right, okay. Then, what is the vertical momentum after collision? Let's check it out. In this direction, right? So, this is mass, what is the mass of ball X? It was 4 kg. What is the mass of ball Y? It was 2.5 kg. Now they have the same velocity, right? So you can just consider them as one big object, m1 plus m2. 4 plus 2.5 multiplied by their velocity v, right? And there you have it. You can calculate v by using this formula. So 2.5 into 9.6 sine 60 divided by 4 plus 2.5 equals to v. And that's how you calculate v in this case. Okay. So that turns out to 2.5 into 9.6 into sine 60 divided by 6.5. The answer is 3.19 or 3.2. That's also right. 2.5 into 9.6 into sine 60 divided by 6.5. Yes, any questions? No? Yes, guys. Abhiya, any questions? All good so far?
Yeah, it's good.
Okay. Yes, Kaima, makes sense?
Yeah.
Okay. Yes, Hania and Ariz, do you see how physics is becoming so easy for you? All because of me.
Becoming quite simple.
It is quite simple. If you just get if you get the idea right and you use the basic principles right and you're careful about the mathematics of it, it is very simple. The problem arises when you're not exposed to the difficult problem. Now, in this difficult example, I'm sure you've learned the law of conservation of momentum, right? You've learned about the directions, you've learned about vector resolution, you've also learned about how to carefully choose the components to find out, which answer to make my working pretty simple. Okay. So that's the entire, purpose of doing questions. In this example, when, we solved the first example, it might have been very confusing and, I don't know what we did. But as we keep solving more questions, you get a good idea of what to do to solve this problem. What's the smartest way to solve this problem? Because we're not going to have, like 1 hour for every question. Okay. That's the entire way of my teaching. We solve one of the most difficult ones. And when we solve one of the most difficult ones, the easy ones are such a piece of cake that, you could do it in your sleep. And that's the goal. You want to do so many questions that you should be able to do them in your sleep. Okay. Now, moving on. Next question. Okay. Okay. Now, two particles A and B collide elastically. Very important. Extremely important word over here. Which means we can use the formula U1 minus U2 equal to V2 minus V1. Very important. Now, the initial velocity of A is 500 meters per second in the x direction and B is at rest. Okay. The velocity of A after the collision is VA. Okay, at 60 degree to the direction of okay. The velocity of B. So okay. We don't know what the velocity is, but we know that it's VA and VB. After collision, they go over here and then this goes over here. The mass of each particle is 1.67 into 10 to the power minus 27. By the way, this is the mass of one atom. Okay. 1.67, or this is the mass of a proton. This is the mass of a proton. Okay. State what is meant by the particles colliding elastically. Yes. What does that mean? Yes, Abiha. Any idea? What does it mean when we say particles collide elastically?
Like that the kinetic energy before is equal to the
Exactly.
kinetic energy after.
Kinetic energy is conserved. Absolutely. 100%. Kinetic energy is conserved. That's the entire point of saying. So kinetic energy is conserved. Okay. Calculate the total initial momentum of A and B. Pretty simple. That's just going to be, total initial momentum. That's just 500 times the mass of the ball of, the particle. 1.67 into 10 to the power minus 27 kilograms. Let's check what that is. So 500 times 1.67 into 10 to the power minus 27. So 8.35 into 10 raised to power minus 25. Okay. State an expression in terms of M, V, A, and VB for the total momentum of A and B after the collision. Okay. Total momentum after the collision in the X direction. What is the total momentum of A and B after the collision in the X direction? So isn't this going to be, it's going to be, wait, do they have the same mass? Two particles A and B collide. Okay. Okay, so mass of each particle is, so both of these have the same mass. Okay. So this is going to be what? This is going to be MVA. What is it going to be? Sine 60 or cos 60? Yes, Kaima. What would be the horizontal component of ball A? MVA cos 60 or sine 60?
Cos 60.
Cos 60, absolutely. It's horizontal. Then, what is going to be the horizontal momentum of ball B? It's going to be M VB cos 30. Okay, that's what they were asking for. Let's write that over here. Okay. So, it's expression of, okay, so this is the total momentum horizontally. So in terms of total momentum of A. Okay. Right. So this is the total momentum in the X direction. What is the total momentum in the Y direction? So that means they're talking about vertically. It's going to be upwards. By how much? It's going to be MVA sine 60. Okay. Then what about the vertical velocity? What about the vertical component of ball V? It's going to be downwards. And what is this going? What is value going to be? MVB sine 30. But it's going to have a negative sign with it. Why? Because they're in opposite directions, right? They're both in opposite directions. If this is going upwards, positive, but if this is going downwards, it's going to be negative. Be careful of the signs. So it's going to be MVA sine 60 minus MVA cos 60. Is that right? No, wait, sorry. MVB cos 60. MVB sine 30. Is that right? So yes, VA sine 60 minus VMV sine 30. Okay. Now, calculate the magnitudes of the velocity VA and VB after the collision. Okay, I'm going to leave this question to you. You have all the information. You have the velocities. Now try to consider what are the magnitudes of VA and VB. Hint is both have the same mass and it's worth 3 marks. Okay, I'll give you like 5 minutes to solve this. Okay. Yes. How to solve it? Yes, Ariz.
I mean, I'm still doing it, so I'm not sure yet.
Okay. Yes, Hania.
I solved for the horizontal components only,
Hmm.
and then I took like, because like after collision the masses are the same, so I took
Hmm.
like the mass as common,
Hmm.
and then I
Okay.
solved for it.
Okay. Okay. That's nice. Yes. Abiha, what do you think?
I'm kind of confused.
Confused? Kaima, any idea?
Wait, the mass is,
The
we know
same.
what the mass is, right?
Yes, we know what it
Oh,
is. It is 1.67 in 10 to the minus
I
27.
thought we had the mass. That's why I was confused.
No, we calculate over here. Now, we know, let's solve it. We know that horizontally and vertically. So horizontally, we know that sum of momentum before should equal to sum of momentum after, right? What is the total horizontal momentum before collision? The ball is only moving vertically initially. So that means the total momentum before collision is zero. What is the total momentum after collision in horizontal direction? It's going to be this value, right? We calculated it over here. It's going to be MVA cos 60 plus MVB cos 30, right? This was the total horizontal momentum in the x direction. Now, we know that M is constant, right? We know that M is constant. So if you take M constant, it's going to be VA cos 60 plus VB cos 30, okay, equal to 0. Understandable. Now, think about it. Do you know what the mass is? Yes, you do. The mass is 1.67 into 10 raised to power is 10 raised to power minus 27 into this entire thing. Okay. Now the problem is there are two unknowns in this variable, right? We know that VA and VB both are unknown. That's so they're both unknown. Okay. Now if we had like at least one of them, then it would make our life much easier. No, but we don't have, right? We don't have both of them. Okay. Now let's try to consider the vertical components. Whenever you have two variables, it's always helpful to come up with another equation in terms of the first variable so that you can try to eliminate a variable. What if I try to eliminate VA? We can do that. Let's try. What about the vertical components? What are the vertical components? No, wait, I think I did something wrong. Horizontally. Oh, right, sorry. What was the horizontal? So this is actually going to be not, this is not 0, right? Because the ball was moving to the right horizontally. So that's just 500 times this, right? So that's going to be 8.35 into 10 to the power minus 25. Okay, okay. 8.35. Okay. So that means we know that 8.35 into 10 to the power minus 25 should equal to this. This is the horizontal momentum equation. Now, since we don't know VA, neither VB, so we'll have to look somewhere else. What is the total vertical momentum? Yes, vertical momentum initially was 0, right? Neither ball is moving vertically. So 0 is equals to, what was the total vertical momentum after collision? They already made us write it. So MVA sine 60 minus MVB sine 30. Okay, okay. So that means that what is M? So M is again constant. No, in fact, you know what? What if I were to make VA the subject in one of these and then plug it in over there? In fact, sorry, this was not a 3-mark question. This was a 4-mark question. Yes. Okay. Now, listen very carefully. I know that what is m into VA? We don't know, what V is. But what if I were to write it as what is the mass? So the mass is 1.67 into 10 to the power minus 27. Okay. So 1.67, in fact, let's just not write it down. It's going to be too long. M into VA sine 60 is going to be equal to M into VB sine 30, right? Why? Because, I just, took that on the other side. What if I were to make VB the subject? I could make either one. I could write this VB, right, over here, right? Would that be fine? Yes. So VB should actually equal to MVA sine 60 divided by M sine 30. Now check this out. Do you see that the M's are going to cancel out? Yes, they are. So what does that mean VB is equal to? VB is equals to VA sine 60 divided by sine 30. Can I plug this VB over here? Yes, I can. I absolutely can. So that means if I were to write down this entire equation over here, okay, and then I were to write down this equation over here, I can absolutely plug that in over there, right? So let's try to plug that in now. Okay, this is like, this is one of the longest questions that we have that for momentum that exists. The first part three, part one, part two, three were pretty easy, but they made sure you catch up in all of the in the third part. Okay, now equals to, rather than writing VB, I can write that in terms of VA, right? So that's going to be VA sine 60 divided by sine 30. Okay, now the problem is trying to get VA out of here. Okay, how do we do that now? Okay, yes, any idea? Are you following me, or have I lost you a long time ago?
No.
No, not following me?
No, I am following you. Yeah.
Okay, 1 second. Acha. So now how do I find out VA? Now this is, after this point is just algebra. Now, how do I find this question out? So first of all, try to do it like this. Let's try to solve for VA. So we know that VA cos 60 plus VA sine 60 over sine 30 multiplied by cos 30. Okay. If I were to take VA common out of this, what would that give me? That would give me cos 60 plus sine 60 divided by sine 30 into cos 30. If you plug that into your calculator, it's going to give you a value. Let's check it out. So if you are weak in mathematics, then this is exactly how you strengthen it. Sine 60 divided by sine 30. What are you saying?
I got 2.
2? Yep, that's
Yeah.
right. So VA times 2. So this entire thing boils down to 2. Okay. Then, wasn't this being multiplied by 1.67 into 10 to the power minus 27? And we know that that value is equals to this value. Now, can you find out VA? Yes, we can. And then if VA is this value, so, plug this in over here, you divide it by 2 times 1.67 into 10 to the power minus 27. So what is this? This is VA. Okay, 8.35 into 10 to the power minus 25 divided by 2 into 1.67 into 10 to the power minus 27. Here it is. VA is 250 meters per second. And there you have it, ladies and gentlemen. After such a long journey, we have finally found water. Now, this is only part of the question. Calculate the magnitudes of VA and VB after collision. So you found out VA, but now we've got to do it again for VB. Just kidding. No, you don't. You just have to do this once. Why? Because you already have a pretty neat little expression for VA, right? If you know this is VA, then you can use this already found out equation for VB to do what? We know that VB is going to be VA 250 multiplied by sine 60 divided by sine 30. And that's how you do this. So 250 answer multiplied by sine 60 divided by sine 30. Answer is VB is 433 meters per second. Sine 60 divided by sine 30. Yep, that's right. 433 is the answer. So that is how you do this question. Okay, now I'm going to go back to the question and just give a little recap. What was we had to find out VA and VB, right? And we know that what is the total magnitude horizontally? Horizontally, momentum initially was this value. And then what was the horizontal momentum after collision? It was this value. Now in this equation, we had two unknowns. We had VA unknown and we had VB unknown. What would be smart is whenever you have two unknowns, you make up another equation and you try to substitute or eliminate a variable using that. Okay. Now I know that I could also calculate the vertical momentum. What was the vertical momentum? Up to this point, it was just pretty simple. Now, what I did was I wrote this equation in terms of VB. Then I could plug in VB over here and then I could eliminate VB, right? Because VB is eliminated. And the new equation is what? The new equation is in terms of VA. Then after this point, it was just mathematics, right? I tried to substitute VA and then because I only had one variable, that way I could find out what V is. Now, because I found out VA, then by using my simpler, equation, VB, I can substitute VA over here and I finally found out what VB is as well. Okay. Now, I'm sure you want to kill yourself after doing this question, but don't worry, not all questions in physics exams are like this, but it is essential that you do these kinds of horrifying questions. I'm sure you would watch a horror movie than, trying to do this on your own. Understandable. I would do. But the point of this is I make you lift the very, very heavy dumbbells, right? The very heavy weights. And once you, lift the very heavy weights, the exam is going to be a piece of cake for you. This is, like level on a scale of 1 to 5. On a scale of 1 to 5, this was, I would say, it would be 4.5, right? On a scale of difficulty. Okay, why? Because you had to connect a lot of concepts together, right? You had to connect, vectors, you had to connect substitution. And the only reason this was difficult is because a lot of students are not great with mathematics because physics, it stopped being physics over here. Once you found out that horizontal momentum is this and vertical momentum is this, after that point, it just stopped being physics. After that point, it was always just mathematics. So if you're great at mathematics, physics will become a piece of cake for you. So all of this after this point was just, solving the mathematical equation and then eliminating a variable and then finding out, or this is kind of like solving simultaneous equations where you try to eliminate a variable. Okay, so that's how you do this question. So yes, the point was to solve a very difficult question so that the exam will seem very easy for you. You solve the extreme ones, and solving one extreme question is like solving 5 regular ones. Okay, in this case, so that's why in class I make you do the very difficult ones so that when you do the topicals on your own, you will be able to do them so easily. They will seem so easy. You will, I'm going to do this in my sleep. Okay. Okay. Yes, Abiha, did you have fun? Did you have fun?
Understood, but
Yes. Okay. Did you get it? Did you get any point which you did not understand?
no, I understood.
Okay. Yes, Kaima, did you get it? I'm sure the maths is
I
horrifying.
got it.
Yes, got it. Will you be able to do it on your own though?
I'll try.
I'll try. Okay, again, try it after class. Try to do it yourself. This is the best practice that you can do. The examples that we do in class, if you just try to do them once on your own and you understand it, just those are very, very, good to help you practice. Because on your own, you might have to do like 5 separate regular questions to get the practice that we do in this class. Okay. So after class, write this down, try to solve it on your own, see where you get stuck, which example do you not get, which part does not make sense to you, because that's the only way that you learn. In this example, only I have learned, I always say this, only I have learned, you have learned, like barely anything. So you'll have to do it once on your own as well. Okay. Sounds good. Yes, Ariz, will you be able to do it?
Yeah, hopefully.
Yes, okay. Now, there was another part to this question. Oh, last question. Uh-huh. Wait, where did it go? Here is the other part. Last part. Calculate the ratio, okay, the ratio kinetic energy of mass 2m divided by the kinetic energy of fragment of mass 1.5 m. What do we do? How do we do that? Mass 2 times m. What is capital M? This m, right? This capital M is this value. Okay. Wait. Calculate the ratio of kinetic energy of frag. Oh, wait, no, this was a different question. Sorry. This was a different question. 1 second. What is the other question? Okay. I'm leaving you with one question as homework. Okay, this was the question. This is your homework question. And I would like you to do it within the remaining time that we have for class. Okay, so you've got like 15 minutes. And I'm giving you this question as homework, as in try to solve it as much as you can, within the remaining time we have for class. I'll send it in the group as well. 1 second. Copy and as much as you can, that's fine. You can, privately text me the answer. Doesn't matter if you had it wrong, if you did not understand a part, you can even circle this specific tiny little step I did not get, but do solve it, because, trying and getting the wrong answer will confirm which concept are you lacking in. But if you do not try and, you leave it till later on, then you might not get it at all. Why can I do this? Okay, let me just take a screenshot. Wait, let me just send it to you. 1 second. Okay, I have sent it in the group and you will be able to find it in the group chat. Okay, solve it, show your working, and then send it to me, within 15 minutes. You have some time, try to think it over. I have also updated the link and you will also be able to find the working for our previous notes in that note. Okay, And that'll be all for today. And I will see you guys on Wednesday. Okay?
All right.
Okay. Okay. Take care. Allah Hafiz. Have fun doing the question.